totally different. So let's move on then. Talk about graphing motion. So if we were talking about graphing distance and displacement and position and which would be easier to graph, let's use actual data from this timeline with the runner. So I'm going to number again one last time. I mean, I say that, but I'm pretty sure this is the last time. I'm pretty sure. Did I do this right? -8, yeah, I'm pretty sure I did this right. 4, 6, 8. Why did I do that? 8, oops. 8 and 10. So let's start by plotting position versus time. We can do that because we have practice during our tumble buggy lab. So I have 5 times, so I'm going to have 5 positions. So I'm going to mark this axis right away. Let's say this is time 1, time 2, 3, time 4, time 5. Skadoosh. Cool beans. And then obviously 0 is there. And then I think I'm going to have to be able to go up to 10. Yeah, I think I'm going to have to be able to go up to 10. So let's do 2. Wait. No, wait. Oh, yeah. 2, 4, 6, 8, 10. Awesome. I went up by tick marks of 1. I'm going to zoom in so you can see that. I just didn't write every tick mark. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Awesome. And for this one, I just went by different increments. So every 2 tick marks is a length of 1. All right. So at time 0, my runner was at a position of 9. So time 0, my runner was at this position. At time 1, my runner was at 6. At time 2, my runner was at 3, which is here. At time 3, my runner was at 0. At time 4, my runner was at 3 again. And then at time 5, my runner was at 6. So my data was looking linear, and then it changed directions. So I'm going to draw 2 lines of best fit to fit the 2 different linear lines. This also looks like an absolute value function. So it could be an absolute value function, but I'm just going to treat it like 2 different lines. Once that object changed direction, something fundamentally changed about its displacement over time. But this graph was fairly straightforward to plot, position versus time. Now let's try doing displacement versus time. Now displacement is my change in position. So I'm still going to mark my axis the same way. So 2, wait, nope, I did that backwards. That's 1, that's 2, that's 3, that's 4, and that's 5. And we're going to do 2, 4, 6, 8, and 10. Same axes. Alrighty then. So at time 0, my runner hasn't moved. So their displacement, their change in position, is 0. At 1 second, my runner has moved from 9 to 6. That's a displacement of -3 units. So holy cow, I didn't even think to mark those tick marks, but I guess I should have. -2, -4, -6, -8, -10. Geez Louise. Okay, so at 1 second, my object went -3 meters. It was displaced -3 meters. Okay. And then at 1 second, or at 2 seconds, what was the displacement there? At 2 seconds, my displacement was from 3 to 9, so that's a total of -6. So -6 would be down here. Okay. Unless my displacement is my displacement between time 1 and time 2. See, I'm not sure now. I'm not sure. What is that displacement measuring my displacement between time intervals, like between 0 and 1 seconds and then between 1 and 2 seconds? Or is it all the displacement from my position at 0 seconds? It's a bit ambiguous, right? Because if I were to do it from 1 to 2 seconds, look at what data I'd get. From 1 to 2 seconds, I went from 6 to 3, which is another displacement of -3. So at 2 seconds, my displacement was still here at -3. And then the next time, from 2 to 3 seconds, I went from 3 to 0, so -3 again, right? So my displacement looks to be the same every time in between each second interval, unless I'm looking back in relation to my 0 second, in which case I'll probably get more linear data. But the point is that this is not a very good graph to describe motion. Why? Because this displacement, I'll make the note here, is ambiguous. Where are we plotting the displacement from? The displacement from position at time 0, or the displacement during time intervals? Whereas position is unvarying. It's not ambiguous. It's pretty clear cut. It's a location at a point in time. You can't really find a displacement at a point in time. You can find a displacement between times. And the question is, are we finding the displacement from time 0 seconds to now? Or are we finding the displacement between 1 second intervals? What are we doing here? So we don't really use displacement versus time as physicists because it's too ambiguous. Now let's talk about distance versus time. So if I plot distance versus time, my graph is going to look the same with the tick marks, 3, 4, and 5. And then we've got 2, 4, 6, 8, and 10. Skadoosh. So if I do my distance, I'm going to erase what I have in purple and do it in blue. My distance is my length of travel. So once again, I'm already starting to think of the same problem. Is my length of travel my length from 0 seconds or my length in between seconds? So for example, my length in between 0 and 1 seconds is 3. So I guess at 1 second, my distance traveled was 3. So I'll plot that. But then my length of travel from 1 to 2 seconds is 3 again. Now, if I were to do my length of travel from 0 seconds, then my length of travel would have been 6. So maybe I should plot two data points, I guess. I could do 3, and then I could do 6, my length of travel. And then from 0 to 3 seconds, or I guess, I don't know, this is too confusing. From 2 to 3 seconds, that's a length of 3. So I guess I could say that it was 3, or I could look from 0 and say, well, the total length traveled from 0 to 3 is 9, so on and so forth. And we're going to see that once again, we end up with the same issue. Distance is ambiguous. Why? Because I can't find my distance at a moment in time. It's always between intervals. So we're not sure when we're talking about distance versus time if we're plotting the distance from 0 seconds to now, or if we're talking about the distance between 1 second intervals or 2 second intervals. It's unclear because at my moment in time, at 1 second, my distance traveled is pretty much the same whether I'm talking about from 0 or starting, because it is the starting. But at 2 seconds, that's where I see the break in my data. I could have data that goes like this, or I could have data that goes like this, right? I see the break in my data when I'm trying to figure out, am I looking at my distance for intervals, like this black line is, or am I looking at my distance from my starting point? Stat, I meant to write start. And the same thing would have happened with displacement. So physicists instead use the most clear-cut way to represent motion. and that is with position. What was the position at this instant in time? What was the position at this instant in time? And then we get away from the whole confusion with what interval are we looking at? Are we looking at from 0 to 1 second or from 2 to 0 seconds? You know what I'm saying? I hope you know what I'm saying. It's so hard to teach to a video when I can't see faces. That being said, how would our tumble buggy graph have changed if we considered direction and position? So for example, let's say that your starting position was, instead of at 0, which is where everyone started, let's say it started at -5 centimeters. And let's say it went in the negative direction. And let's say it went in the negative direction. I think this number line is a little bit smaller. Is it a little bit smaller? Let me double check with how it was supposed to look. I've got it pulled up here on another screen. Yeah, I knew it was smaller. So let's say that this is -10, -9, -8, -7, -6, -5, -4, -3, -2, -1, 0. So let's say our buggy started at -5 and went in the negative direction. What I would see from my data, or on this number line, are points that move equal lengths every second in the negative direction. My positions would be getting more and more negative. So this might be where the buggy was at 0 seconds, and maybe this is where the buggy was at 1 second. And maybe this is where the buggy was at 2 seconds, and at 3 seconds, and at 4 seconds, so on and so forth. And at 5 seconds, so on and so forth. So it's not a huge difference in the motion as much as it is in how we communicate the motion of the buggy. It starts in a negative position and it goes in a negative direction. So on my graph, I might have seen data that instead of looked linear with a positive slope and with an intercept of 0, I might have seen data, I guess I should change my graph actually. If this was a position versus time graph, I would have seen a negative y-intercept and a line with a negative slope, because those positions would be getting more and more negative. Now, how would our tumble buggy graph change if instead we started at -5 centimeters and moved in the positive direction? So let's say my tick marks now look like this: -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. So a lot of you guys included a whiteboard or a wall in your data, in your data collection, so you actually saw a change in direction. So this will probably better reflect your data. Now let's say instead of starting at 0, we started at a negative value, like -5, and moved in the positive direction. I'd see my buggy moving to more and more positive values, and then after hitting the wall, it would change direction, producing lines or dots like this. Now, how would that look on a graph? Oops, I needed that again. Well, it looked kind of similar to my last graph where I had a -5 intercept. My starting position would be -5. But now that my values are going in the positive direction, I'd see more and more positive values. And then when it hit 0, it went to position 1, and then it changed directions and it started becoming more negative. So I would see, kind of similar to what we saw with the runner, a line that looks like an absolute value function, or a graph that looks like an absolute value function, or two linear lines, because there's a change in direction where my values are becoming more positive and then it starts becoming more negative. You might have noticed that this is an initial direction. That's because the direction in this setup changes once it hits the wall. And we see that change on a graph with a change in slope. A positive direction equals a positive slope. A negative direction of travel equals a negative slope. So we're going to get more practice with these big ideas. I know that this was quite a bit for one lesson. So what we're going to do is just do some basic general practice, and we'll continue to explore these ideas until they're cemented in our mind and our understanding. So for now, go ahead and move on to the aligned practice that goes with this